welcome to lesson 31.3. Today's lesson is going to be a supplemental note sheet that you can either print off from Google Classroom or just take the notes in a notebook. You will also want a pencil and a calculator. So on the supplemental note sheet, we see some different things about perimeter of regular polygons. And notice we have a pentagon here. And if it's a regular polygon, we talked about before how that means all the sides and all the angles are the same side. So if we want the area, we're going to either add up 5 times 28, or you could say 28 times 5, since you're adding that up 5 times. You'd get a total of 140 centimeters, right? Remember, centimeters, not centimeters squared. We also know that if we have a hexagon, so a 6-sided figure, we would have to add up 14 6 times, aka 6 times 14. Again, if you're adding it up 6 times, 84 inches. Or an octagon, which is an 8-sided figure, those would be adding up 23 8 times, aka 8 times 23, be 184. So basically what we could say when it's a regular polygon, so when all the sides are all the same for regular polygons, the perimeter is equal to the number of sides times your side length, right? N times S. Now there is a new vocab word given here, and this vocab word is called an apothem, or some people say apothem. So apothem or apothem, but most people say apothem, I believe. And the apothem is a perpendicular segment from a midpoint of a side of a regular polygon to the center of a polygon. So we are, again, dealing with regular polygons. And again, it's going from this midpoint to the center. So if you have an apothem, you know you're going to have this side being bisected because it's a midpoint. And again, this is called the apothem from that midpoint to the center, okay? Now, when we have a polygon here, we want to draw and label that apothem. So that's going to again come from the center to the midpoint. And if we draw in this small triangle, again, what's happening is this is getting bisected. And also this angle is getting bisected into 2 congruent angles, okay? Now the apothem here is also going to be known as the perpendicular bisector of that side that we drew in. So notice it would create this right angle and it cut it into 2 congruent pieces. And overall, this angle up here, we know that angle is going to be 360 divided by the number of sides, the whole angle there. Because we could draw in this case, 6 of these triangles here, and so we would divide it by 6. But we're going to then divide it by 2 to get the smaller angles. Those baby angles that we have in there. In this case, the blue, right? So I'm going to put that in there so we don't forget. So again, this is getting bisected, whatever that angle measure is, divided by 2. Now, why are we talking about this? Well, there is a special formula for the area of regular polygons, and it's going to be 1/2 the apothem times the perimeter of the polygon. What I like to call half ap, okay? Think about if you're hungry, you like half price appetizers, right? Half ap, it's a good deal. And that's how we're going to get that area, okay? So for example 3 here, we have the area of a regular octagon, so an 8-sided figure, with a side length of 7 meters. So the side length is equal to 7, and the apothem length is 8.4, okay? So this is going to be little a is 8.4. Well, again, our formula of the day is half ap. And the good news is they gave us part of this. They gave us little a. The a part of this is 8.4. The problem is we need to get the perimeter of our octagon. Well, a reminder from the beginning, the perimeter of a regular polygon is n times s, right? N times s, the number of sides times the side length, right? Because if we had that 8-sided figure that you might possibly want to visualize here, we know that each of the sides are 7. Oops. So we would have to add that up 8 times. So the perimeter is 8 times 7, n times s, number of sides times side length. So a total of 56. Okay. So plug that in. And then we have our final answer here. If we take 1/2 times 8.4 times 56, we get a total of 235.2 meters this time. Meters was our length. Okay, let's try another one. Okay, a couple more examples. The next one is asking us for the area of this regular polygon. And again, we have this time an octagon. So we have to be careful though on this octagon because they're not giving us our little a this time. We're going to have to find it. Now, something they did give us is obviously the number of sides is 8 and the side length is also 8, right? So our perimeter here, we have 8 sides and they're each 8 units long. So the perimeter is 64, right? Now, the problem with this though is we're going to have to find the apothem length. So this is where we're going to take this angle here. And to get this big angle Q, it's 360 degrees, total number of degrees, divided by the number of sides, which is 8. Okay. So this total thing right here is 45 degrees. But we only want half of this, right? So half of 45 is 22.5. That's that little angle up there. So each angle is half of that, so 22.5. Now, your buddy on this is going to be tangent because we have this angle here. We want the opposite and we're looking for the adjacent. And the reason we're using tangent is because we know this whole side is 8, so each piece would be 4. So we have the angle is 22.5. We have the opposite is 4. We're looking for the adjacent, which is the apothem. So switch and divide. We're going to get that the apothem equals 4 divided by the tangent of 22.5. Now, something that you are going to want to do is make sure that your calculator is in the correct mode. Remember, we like degrees mode, not radians mode. So you want to make sure that DEG is highlighted. So then 4 divided by the tangent of 22.5. Oops. 5 is going to equal 9.7. Okay, so 9.7 is the length of our apothem. Finally, we have that apothem to be able to plug into half ap, so 1/2 apothem times the perimeter, which we had way back up top here was 64. Half of that, this would be 310.4. All right, now a pentagon with this kind of length. Again, if we draw in, we know pentagons have 5 sides. Okay, 5 sides on that. And the side length is 12. So this angle here is going to be found by taking 360 divided by the number of sides, which is 72. But we only want half of it. So half of that is going to be 36 degrees. And we're looking for the apothem, and the side length we know was 12, so each piece is 6. So again, tangent is your buddy. Tangent of 36 this time is equal to the opposite over the adjacent. Switch and divide again. So this time we should already be in degrees mode. 6 divided by the tangent of 36, it's going to give us 8.3 as the length of our apothem. So as we're plugging in, we have 1/2 the apothem, and then we need the perimeter of this figure. Well, remember the perimeter of a pentagon is going to be the number of sides times the side length n times s for a total of 60. So half of 8.3 times 60 is 249. Next, we have this hexagon, okay? And a hexagon is a 6-sided figure with the side length of 18. So we're going to start with that perimeter is number of sides times the side length, n times s. So 6 times 18 is 108. And then we need the apothem length. So again, if we draw in that little triangle, we know this whole angle is 360 divided by the number of sides, so 6. So that would be a total of 60 degrees, but we only want half, so each angle is 30. Now our side length, we said from up above, is 18, which means each piece is 9. So as we try to find that apothem length, again, our buddy is tangent, okay? Tangent of 30 equals opposite over adjacent, right? O over A, opposite over adjacent, switch and divide. 9 divided by the tangent of 30 is going to give us a value of 9 divided by tan 30, 15.6. So our final answer, the area is 1/2 apothem times perimeter for a total of 841.8 square feet. All right, last but not least, we have an octagon with a side length of 9 inches, okay? So again, an octagon has 8 sides. Side length is 9. Perimeter equals n times s. 8 times 9 is 72, okay? The central angle of this is always 360 divided by the number of sides. So we talked about this actually kind of up in this example here. It's the same process as what we talked about right here. So these are 45, but we want the apothem. So we really only need half of that, which is 22.5. So you're going to see anytime you have an octagon, you're dealing with this same values for all of these. Okay, so you'll notice that pattern continue, that you're kind of using those same values depending on your shape. So the side length this time is 9, which means this is 4.5 and this is 4.5. And remember, tangent is your buddy. Tangent of the angle is equal to the opposite side over the adjacent side, or the apothem this time. Switch and divide. 4.5 divided by the tangent of 22.5. Type that in. 4.5 divided by tangent 22.5 is about 10.9. Okay. Last but not least, plug this in. Half ap, 1/2 apothem times perimeter equals 392.4. Okay. So each time you're doing the same process, okay? You want to start by finding your perimeter using n times s, number of sides times side length. You'll find your apothem if they don't give it to you. If they don't give it to you, it's going to be tangent of the half angle, right? And then that's the side divided by 2 divided by the Apothem, right? And then last but not least, plug in to half out, okay? We will work more with this in class. Thanks for watching.